Okay, good day, everyone. I wish you had great fun with Colin last week. Today, I'm going to give you a brief introduction on the Android platform, and I'm also going to walk you through the various features provided by Android Studio. Particularly, I'm going to show you how to debug your code in Android Studio. Okay, and if time permits, I will also talk about the model view controller design pattern and the various types of Android application components. So let's get started. I think you should already know what Android is, right? It's a mobile operating system, but you may not know that maybe 10 years ago or 20 years ago, there are many different mobile operating systems um, in the market, okay, including the Palm OS, BlackBerry, and J2ME, Brew from Qualcomm, and then Symbian from Nokia, and iOS from Apple, and the Windows Mobile from Microsoft, okay? And you can see that most of the mobile platforms on the list have died, okay? BlackBerry might be still, there, but it's dying, right? But the key point is that there are so many different platforms at that time, and it's a nightmare and really painful for application developers or software companies and headset manufacturers because um, they will have to, in order to have the application to be able to run on such many different platforms is going to take a lot of, efforts, okay? And Google, of course, Google stumbled on the same problem, okay? So that's why in 2007, Google and a lot of companies from um, the industry, including mobile phone manufacturers such as HTC, T-Mobile, G1, and the mobile operators such as Verizon and content providers. Content providers are application developers or application providers or companies. They decided to establish something that is called the Open Handset Alliance in 2007. Okay, so so the Open Handset Alliance decided that they are going to use a unified mobile platform, and that is the Android operating system provided by Google. And one thing you may not know is that Google was not actually originated from Google. Okay, so Android was developed by a company called the Android Inc. Okay, and Andy Rubin was widely considered as the father of the Android platform, and Android Inc. was acquired by Google in 2005. Okay, so that's how Google acquired the Android operating system, the Android or the Android platform. Okay, so that's where the Android operating system comes from. And this figure shows the Android development architecture, and you can see there are um, 5 layers, okay, in total. And our applications, user applications and system applications live at the top layer, okay, including email application, calendar application, Google Map, and browsers, so on and so forth. All the application sits on the top layer. And the second layer is the Java API framework. Um, so all the features for Android development are available through this layer, including the UI components. And this layer is also responsible for resource management and, more importantly, the lifecycle management for applications or app components or UI components. Okay, and because you can see that all the application now live inside the Java API framework, so the programming paradigm um, have shifted has shifted to event-driven programming. Okay, so that is an application can have multiple entry points. Okay, it is it's not like what we are used to, right? So when we were studying C++ or Java programming, there's only one single entry point for an application. That is the main function, okay? But now things, all the application live inside a framework, okay? So now every time a framework sends a signal to an application, then an application can react to that event. Okay, so that means an application can have multiple entry points. So for example, suppose your application is capable of playing music or video, all right? And suppose the user is using your application, watching some video or listening to some music. And now suppose a phone call comes in, and the application is gonna bring up the phone app and push your application back into the background, okay? And this time, the Java API framework is going to notify your application saying, hey, I'm going to push you into the background, and maybe you should do something, okay? So at this time, your application should pause the playback of a video or music, right? Because you know, the user cannot see the video when your application in the background, right? So there's no reason for wasting the battery power. You know, keep playing the video in the background. So at this time, you can stop or pause playing the music or playing the video, and when the phone call ends, the framework is gonna bring your app back to the foreground, okay? And at this time, the framework is going to notify you saying, hey, I'm going to bring you to the foreground again, and then you should do something, okay, if you want. Okay, so this time, we can resume the playback of the video or the music that the user was listening to or watching. So that's the job for the API framework. Okay, resource management and lifecycle management for application components. So the next layer is the Android runtime. So the Android runtime, this layer includes the Java virtual machine actually, and the native C and C++ libraries required by the Java virtual machine. So in Android, each app runs in its own process within its own instance of the Android runtime or Android Java virtual machine. In Android, each application is actually modeled as a separate user. Okay, so if you have used, you know, multi-user, multitasking operating system before, such as Unix or Mac, and then you probably know that in a multi-user operating system, a user cannot arbitrarily access the files or resources owned by the other user or other users, right? And there's no difference in Android. Okay, so and since each application is modeled or treated as a separate user, so that means an application cannot arbitrarily access the memory space or the files or other resources owned by the other applications. Okay, and suppose you wanted to, you know, share some data, share some resources with our other application, then you have to go through something we call content provider, and we will talk about content provider if time permits later in the semester. Okay, but one important thing to keep in mind is that one application cannot arbitrarily access the resources, the memory space, so on and so forth, owned by other applications. Okay, and as mentioned earlier, this layer also contains the native C and C++ libraries that are required by many core Android system components, especially the Android Java machine. And these native libraries are also available to the upper layer applications, to the API framework, through the API framework. Okay, so the next layer is the hardware abstraction layer, also known as HAL. So basically, this layer provides standard interfaces that expose device hardware capabilities to the higher layers. The HL hardware abstraction layer consists of multiple library modules, each of which implements an interface for a specific type of hardware components, such as the camera or Bluetooth module, so on and so forth. And the layer sits at the bottom, and that's the foundation of the Android platform, which is a Linux kernel, okay, which is very interesting. So now you know that Android is actually a Linux variant, okay. You might do. I'm not sure if you have ever heard of Linux before, but Linux is um, a, a, um, a string of the Unix operating system. It's a Unix-like operating system, okay? So the kernel is usually written in C, the C programming language for efficiency reasons, okay? It's not even C++. And the kernel, um, um, the higher layers mentioned above, such as the hardware abstraction layer, the Android runtime, the Java API framework, so on and so forth, the upper layers, they all rely on the kernel, okay, to provide, thread management, low-level memory management, file system management, so on and so forth. Okay, so this is a very important layer. So now we are done with the Android architecture, and let's move on to the Android Studio basics. Okay, so let me show you Android Studio. Okay, so let me start my Android Studio on my computer. Okay, I'm going to close the project first, okay, because we are not here yet. I'm going to close the project. Okay, so if you launch Android Studio, this is the screen you are going to see, or the window that you're going to see. And this window might be a little bit different from what you are going to see on your computer, because if you have never opened, or if you have never created any project using Android Studio, the window is going to be different. I'm going to show you the one that you might see, okay? So if you have never created any project or opened any old projects on your computer system, this is the window you are going to see, okay? So you might be wondering, hey, where is the three dot button that I showed you during the first week of the class? In this window, on this window, you cannot, there's no three dot buttons, okay? So, but you might be wondering how you can find the SDK manager and the AVD manager, okay? Well, they can be found over here by clicking the more actions link, okay? So once you click on the link, you can see the same menu that I have shown you in the first week of the semester, okay? So you can see the SDK manager. So let's start the SDK manager. So as mentioned earlier, SDK Manager allows you to manage the SDKs on your computer system. And you can see there are many different Android SDKs, starting from Android 2.1, which is really old, to the latest one, Android Tiramisu Preview. Okay, this is not even released yet. Okay, if you click on the Show Package Details, you can show the components that have installed or can be installed on your computer system, okay, in detail, okay. And when you decided to install a particular version of SDK, you do not, okay. So let me try to emphasize this. You do not have to install everything, okay. So for example, I have Android 11, okay, installed on my computer system, and you can see I only installed two components. One is Android SDK platform, okay. This is required if you wanted to, develop app, and this is the one you need. and to run to test your application, you are going to need a system image. Okay, so that's why I also installed this one, Google API Intel x86 Atom 64 system image on my computer. And for the rest, they are not necessary. Okay, it's going to, if you install, that's okay, but that's going to be a waste of your disk space. Okay, so on the second tab, this is the SDK tools that we talked about in the first week, and make sure you have Android emulator installed, and if you have Intel CPU, make sure install this Intel emulator accelerator as well. And as to the SDK update sites, well, we don't need to change anything over here, so ignore it for now. Okay, so that's all I wanted to talk about SDK. So now let's move on to the virtual device manager, aka the AVD manager, okay, Android virtual device manager. And you can see the Android device manager is going to list all the emulators that you created or defined in the past. Okay, so you can see I have two different emulators. Okay, here in my device manager, one is a Android phone emulator, and the other one is a Android tab emulator. Okay, and in case you wanted to edit or change the properties of the Android emulator, you can always click on this pencil or pen button over here to launch the Android virtual device editor. Okay, and here you can change the name for your AVD, and you can also change the system image. Okay, and it's okay to choose any system image you want. Okay, just don't choose a system image that's really old. Okay, choose a more recent one. Okay, and usually I would recommend you to choose the one from this recommended list. Okay, and of course this is the recommended list, and of course you can choose any one from this list as well, the x86 images. Okay. And here, inside the Android virtual device editor, you can also change the startup orientations for your emulator. You can set it to portrait or landscape, and you can change the emulator performance for your graphics. Okay, and if you have a really powerful graphics card installed on your computer system, you can change the graphics from automatic to hardware. Okay, so that the graphics rendering is going to be faster. And if you do not have a very powerful graphics card, or the emulator, doesn't even run on your computer, then you may try to change the graphics option to software emulation. Okay, so normally I simply leave it to. I usually don't touch this option. I usually set it to automatic. And if you want to show the device frame, you can check this. Okay, and by clicking the show advanced settings, you can change or modify some of the advanced settings for your emulator. Okay, so for example, you can change the option, the boot option, to cold boot. Okay, if you want to cold boot your emulator every time you start your emulator, but it's going to be very slow. So usually I set the boot option to quick boot. Okay, quick boot. And here you can allocate one or multiple, usually two CPU cores to the emulator, and you can also change the amount of memory space allocated to your AVD. You can change the heap size, the emulated internal storage, and the emulated storage for SD card. Okay, you can change 512 megabytes to something else. Okay, But normally I don't, I don't change these settings. Okay, I just leave them untouched. Okay, so once you are done, simply click finish. Okay, and in case you want to create a new virtual device, simply click on this create device. Okay, okay, very simple. So this is a very quick instruction to the SDK manager and the um, um, AVD manager, virtual device manager. Okay, so I'm going to walk you through the various features provided by Android Studio. Okay, so let me open a project first. Okay, so this is the user interface of Android Studio. On the upper right corner, you can see a toolbar over here. And the toolbar allows you to specify the device you'd like to use for testing your application. And here you can see all the virtual device that you created using the AVD manager, okay? And of course, you can also connect your phone to Android Studio, and you can even debug the application that you are developing using your real phone, your physical phone. Okay, so how can we connect our phone to Android Studio? Well, before connecting your phone to your computer, there's one thing you need to do. Okay, and I'm going to go back to the slides to show you what you need to do, okay? So basically to connect your cell phone to the Android Studio, you need to enable something we call the developer's options on your device, okay? And to enable developer's option, you need to go to settings, systems, about phone, and click on software information, tap the software information 7 times, tap on the build number actually, okay? Tap it for 7 times, and then the developer options will be enabled, okay? So once the developer options is enabled, you can go to settings, systems, then you will able to see the developer's options over there, then go in that menu and enable USB debugging inside developer's options menu, okay? And once you are done, oh, by the way, how we can enable developers option, it can vary from device to device, but the important thing to know is that you need to find the build number for your software, okay, for your user interface. Now, I have enabled the developers options on my device. I have also turned on the USB debugging feature. So now I'm going to connect my phone to my computer using a USB cable. Okay. So now you can see that my physical device, my phone, now shows up, okay, on the list. Okay, it's the first one actually. It's Xiaomi M2102K1AC. Okay, so I'm using a very cheap cell phone because teachers are uh, pretty poor in Taiwan. Okay, the salaries for teachers in Taiwan is very low. Okay. Okay, so if you choose your device, you can run and debug your application using your phone inside Android Studio. Okay. So in addition to selecting the device you would like to use for debugging your application, you can see there are a few other actions that we can do on the toolbar. Okay, the first one is this green triangle play button. Okay, so this button is used for run your app on your selected device over here. Okay, and this green button is for debugging. Okay, this is for debugging your application on your selected device. And this one is for synchronize the Gradle files with the project. We'll talk about what Gradle means later, okay? And this button is for launching the device manager, the AVD manager, and this button is for launching the SDK manager, okay? And on the left-hand side, okay, you can see something we call the navigation bar, okay? And you can see that the navigation bar shows the path of the file you are editing, okay? So you can see this file is under the path that is called iTunes Listener App, src, main, java, tw, edu, nzku, imr. This is actually the package name, okay? The package name also coincide with the path of this file. Okay, so if you click on this, you can see all the files inside this folder, okay, under this path. Okay, but normally I don't use navigation bar as much because we can always see or open or switch between files using the project explorer on the left-hand side over here. Okay, so anyway, this is the navigation bar. Next, so the next thing you'll notice that there's a big area over here. This is what we call the editor window. And this is where we create and modify our code, okay? Depending on the current file type, the editor can change. Okay, so for example, if you are, viewing a coding file, it's going to show a text editor or code editor. But in case you open a layout file, okay, in case you open a layout file, it's going to bring up the layout editor. So depending on the current file type, the editor can change, okay? So this is the editor window. And the editor window of Android Studio is very powerful, actually. It provides a very, very nice feature that is known as code completion. And so code completion means, as you type in the editor window, Android Studio is going to help you complete the code by providing suggestions for variable names or function names, or even adding missing parentheses, brackets, and braces, so on and so forth. And what's even better is that, the code completion can be context aware, okay? Meaning that, when you are typing the code, it's going to display relevant options based on the context. Okay, this is something we call smart code completion. Okay, so for example, I'm going to type something over here, such as media player dot. Okay, so once as you type, the Android Studio is going to know, hey, you might be you might want to access some properties or invoke some methods on this media player object. So it's going to show all the properties and all the functions available on this object. Okay, and another example is when you are, trying to invoke a function and suppose you are trying to pass some parameters to that function, then the Android Studio is going to, depend on the type, depend on the data type of the parameters. The Android Studio is going to show all the list of all the objects, okay, that can be passed as the parameters to that function that you are going to call, okay? So this is a smart code completion. I really like this feature, and I think you will like it too in the semester, okay? Okay, so that's the editor window. So I think the next one is the tool window bar. Okay, so basically the tool window bar runs around the outside of the IDE window of Android Studio. Okay, so you can see this is the a tool window bar. Okay, so the tool window bar on the left, it contains the project tool window. It contains the resource manager tool window and a few others. Okay, and at the bottom we also have another tool window bar, and this tool window bar contains to do. Okay, so the to do is going to show you all the to-dos, okay, that you added in code. Okay, uh, 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 suppose you feel tired, you need to go to sleep, and you want to take a break, okay. And in case you can put down some to do or memo, okay, in your code like this, okay, in case you forget to do something, okay, in your code. So this to-do tool window is going to show you all the to-dos that the to-do memos that you write or you put down in your code over here. Okay, so you don't have to memorize everything. You can simply put down the list of things you want to do over here, and it's going to show you. Okay. And another tool window is this, another commonly used tool window is this logcat, okay? So logcat is going to show you the debugging information, okay? And normally debugging information have many different priorities, including verbose, debug, information only, and warning, and errors, and asserts, okay? So they are going to show you all the debugging messages over here inside this logcat window, and you can filter the debugging messages by their priorities using this Dropbox. You can also search for the debugging information you are looking for using this search box, and this search box even supports regular expression. Okay, if you don't know what regular expression means, simply look it up on Google. Okay. And on the right-hand side, there's yet another tool window bar, and this tool window bar contains the Gradle, okay, and device manager, device explorer. Device explorer is going to show you the file system of your selected device, okay. So you can see this is the file system of my physical phone, okay. And you can also see the device, emulator tool window over here. Okay, so this is a very quick tour to the Android Studio, the user interface of Android Studio. Okay, so now let's go back to the Project Explorer over here on the Project Explorer tool window. Okay. So the Project Explorer shows the project structure of Android Studio projects, okay? And you can see that each project contain, two folders. The first one is app. The second one is Gradle scripts, okay? And the app folder contains three subfolders, and they are a manifest folder, the Java folder, and the resource folder, or RES folder, okay? And you can see that the manifest folder contains one and a single one file, that is Android manifest file.xml. And this file is a very, very, very important file, okay? And this file is important because, uh, you know, uh, because it includes the package name of your application. Okay, this is very important information. And secondly, it describes all the components inside your application. Okay, you have to list all the components in your application here inside this Android manifest file. Otherwise, the operating system won't be able to see the components inside your application. Okay, so it's important to memorize, to to put or to list all the components in your app here in this file. And another reason why this file is important because we need to declare all the permissions that are needed by our app over here on the top, okay? So for example, this application requires internet access, okay? So that's why I listed the permission for internet over here, okay? If you don't list the permission over here, then Android won't allow you to access internet or won't allow you to access the resources you need, okay? So this is what we call the least privilege access, okay? So Android designed this way for security reasons, okay? If you don't need anything, then Android won't give you the permission, okay, to access the resource you need during the runtime, okay? So be sure to put all the permissions you need here in this Android manifest file, no matter it's internet access or camera or Bluetooth or even GPS information for the user. You need to put all the permissions over here inside this file. And some information or some permissions are very sensitive, such as the GPS information or GPS location of the user, okay? It's a very sensitive information regarding the user. And in that case, you not only have to put the permission in the central manifest file, you even need to make a request at runtime and have the user to grant the permission, okay, to you, okay? And I will tell you how to ask for permissions at runtime later in the semester. Okay, so this is Android manifest file, a very important file. Okay, now you can also see the Java folder over here. The Java folder contains the package in which we can find all the source files in the package. Okay, and a third subfolder here is the resource folder. The resource folder contains all the resources, including icons, aka drawables, layout files, navigation graphs, and all the constants such as colors, dimensions, strings, and themes. They are all put inside the values subfolder or resource subfolder. Okay, so now the Gradle system. Okay, so Android Studio uses Gradle as the foundation of the build system, okay? And using the Gradle files, we can customize the build process, okay? We can create multiple APKs for our app with different features, okay? So for example, free version and the paid versions of app, they may offer different features, okay? And using a Gradle system, we can control which feature to be included into which version of the APKs, okay? And you can see there are two different Gradle files over here. The first one is the project level Gradle file, and the second one is the module level Gradle file. And we rarely change the project level Gradle file. Okay, so the project level Gradle file simply allows us to configure the calling version we'd like to use. Okay, the navigation plugin, the version for the navigation plugin. We'll talk about navigation plugin later in the semester. And the module level Gradle file, okay, is more interesting, okay, because it allows us to configure the compile SDK version, the minimum SDK version required for running our application, the target SDK version, okay, and the libraries or dependencies required by our application. We need to list all the libraries or dependencies required by our application here inside the module level Gradle file. Okay. And Now, let me show you the emulator. Okay, so I'm going to use this one, Nexus 5. So this emulator is running Android SDK 29. Okay, so let me run this app. Let me run this app on the on this emulator. Okay, so once you hit the run button, the Android Studio is going to compile the code and then install the application onto the emulator and launch the application inside the emulator. Okay. So this application is called the iTunes Listener. Okay, so we will be working with this application throughout the semester. Okay, so basically what this application does is that it's going to download the list of the most popular 25 songs on iTunes. iTunes is a music service provided by Apple, right? So this app is going to fetch the most popular 25 songs or 20 songs. I'm not sure the number. It's either 20 or 25. Okay, it's going to download a list of the most popular songs from iTunes, and the user can click any song on the list and preview the song. Okay. Okay, so now you can see the Android Studio still, the Gradle is building the application. So you can see this Gradle build running on the status bar of Android Studio. Okay, so now you can see it's done compiling. So now it's installing the app onto or into the emulator, and now it's starting the app. Okay, so this is the list of the most popular songs on iTunes. Okay, and so now I'm going to select one of them. Okay, so I can preview the song over here. Okay, inside the app. Okay, so using the emulator, you can also change the orientation at runtime by clicking this rotate to left or rotate to right button. Okay, and you can also take a snapshot of the screen by clicking this camera button, and you can, let me see, go to the home screen by clicking this button and go back to the previous screen, or go to the overview screen over here. And if you click on this expanded control button over here, okay, there are many more things you can do over here, okay? You can, for example, emulate phone calls using this tab. You can even feed, fake GPS signals to the emulator over here. Okay, say I'm going to feed this. This is NCKU, by the way. So I can feed this, fake GPS signal to the emulator by using or by clicking on the set location button. Okay. So there are many interesting thing you can do over here. I'll just leave it for you to explore. Okay, I'm not going to go through every options on over here on this window. Okay, now in case you find your computer is not able to run the emulator well, one thing you can do is reboot your computer, okay? And when rebooting your computer system, go to your BIOS, okay, by either pressing the ESC escape button or the delete button on your keyboard, then or F2, okay, the function key F2, then you should be able to go into your BIOS, okay? And once inside your BIOS system, be sure to turn on virtualization, okay? If you are using if you have a Intel CPU, but if you have an AMD-based system, make sure you have SVM mode option turned on or enabled, okay? Otherwise, emulator won't be able to run on your computer, okay? In case you have done everything and you still cannot get the emulator to run on your computer, my suggestion is you can, if you have the money, if you have the budget, you can try to get a new computer, okay, for this course, okay. But I normally don't recommend this because it's going to cost you a fortune, okay. A regular computer takes, or cost at least maybe 20,000 Taiwan dollars, right? New Taiwan dollars. So it's a lot of money. Instead of buying a new computer, you can, you are always welcome to use the computers in our computer uh, classroom, okay, on the second floor. Okay. Okay, so I think I've talked enough for this hour. I'm going to take a break now. Oh, by the way, before taking a break, um, there's a lab for you. Okay, so this is lab one. So in this lab, you'll learn how to build a basic Android application in Android Studio, and learn how to create an Android project from a template, and learn how to find the major components of Android Studio project and how to run an Android app on the emulator or physical device. So basically, this lab, if you do this lab, you will be familiar with the Android Studio. The user interface of Android Studio will help you to familiarize with the user interface of Android Studio. Okay, so let's take a break.